Hello guys, my name is Balkrishna Shrivastava and welcome to CodeWithBK. So in this video, we write a C++ program to print the frequency of characters in a string and we use an STL map in this case. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 4 or 5 are subscribed. More than 95% of my audience is not subscribed and a subscription is very important. So please do subscribe to my channel. So let's begin. So we have to write a C++ program to print the frequency of characters in a string, and I've already posted a video on this in which I cover two methods. One of those is a brute force method where just we have to get the right output, and the other method was sorting, which was a little more optimized. Okay. In this case, we use an STL map. We see how a map is used to store key value pairs, and we also try to make the runtime of this problem as fast as possible. Okay. So these are the examples. The first example of the string is this. Okay. This is the expected output, each character with its frequency. So uppercase S occurs once, lowercase a occurs twice, lowercase c once, lowercase h once, till all the characters. For the second case, uppercase j occurs once, lowercase a twice, lowercase v once. Okay. So I have included the STL map to be used. I'm going to write a function void print frequency of characters. Okay. And it takes a string s. Okay. All right. Map is a part of STL. STL is standard template library. Okay, these are templates as the word suggests. Maps can store key value pairs. So how do we use a map in this case? I'll say, let me just take a map first. I'll say map. Okay, and my key is going to be the character of which I need to store the frequency, and my value is going to be the integer. Okay, the frequency for this character, and I name this map frequencies. Okay, that's how you create a map. Okay, the type for the key and the type for the value. Okay. Now, how do I add values to this map? I'm going to iterate this string from left to right. I'm going to pick up each character in each iteration, and I will add that character to the map. How? I will say iterate the string from left to right s.length. Okay, I plus plus. Okay, get the character at ith index as s of I. So map can store key value pairs. Our key is this character, and the value, the integer, is the frequency. So if this character has not been added in this map as a key so far, I add this character in this map as a key. Okay. And since I'll be adding this character for the first time in this map as a key, I want the value for this particular character to be 1. That is, if ch is not found in this map. Now, how do you check that? You say frequencies.find. Okay. The name of the map, finding this ch if it is equal to frequencies dot end. Okay, you reach at the end. Okay, the end iterator is returned, that is the ch is not found. So if ch is not found as a key in this map, okay, in this case add ch as the key, okay, with value 1. Okay, the understanding out of this is we are adding ch with value 1. We are adding the character ch with frequency 1 because it's the first time we are facing this character ch, okay, from this string. Okay, so how do we do that? You set frequencies of ch equal to 1. This is the syntax. Okay, the key, the value. Else, now else part would be that I have added this ch, the same character ch, in some previous iteration, so that this returns false. That is, this ch is already in this map as a key. Okay, now if ch is already in this map as a key, I don't want to add ch again as a key. Okay, because keys will be unique, right? I just want to increment the frequency, the corresponding value for this key, so that the count for this character is increased by 1 because values will be the corresponding frequencies of the character. Okay, so else part would be increment the frequency of this character by 1. Now, how do you do that? Okay, you say the value at this key plus plus. Okay, and now this for loop is going to add all characters of this string. Okay, all unique characters of this string as keys, and their values will be the corresponding frequencies on how many times each character occurs in this string. Okay, all the keys are going to be unique in this case. Okay, so let me just print, right? All right, now how do you print a map? You can iterate the map, okay, using auto, or you will use the iterator here. Okay, C++11 onwards you can use the keyword auto, but I'm going to go with the old way. I'm going to say I want an iterator of this type, okay, which starts at the beginning of this frequency. Okay, this is how you usually iterate STLs in C++. Okay, you start from beginning, you go till the end. It is not equal to this frequencies dot end. Okay, and this identifier it is just a convention, right? It's short for iterator. Okay, and in each iteration we do it plus plus. Okay, then we say cout. We have to print the output as character followed by frequency, right? So character is going to be, now this it is a pointer, so we use this arrow thing, right? It's first value is going to be the key followed by colon followed by the second value, which is going to be the value for this, the value for this key. Okay, so printing key and printing value for each of this element using this iterator. Okay, right? So this is a code to find the frequency of characters in the string using STL map. Now let me just take a string in the main. String s is Sachin Tendulkar. Okay, calling this function. Okay, I should get an output something like this. Okay, not exactly like this. I won't get an exact output like this. Right? The order will be different. I'll tell you why. So I compile. Okay. Okay. So you see my values are correct. That is, for each character I get the right count. Okay. So in this case we know that uppercase s is 1, uppercase s is 1, lowercase a is 2, lowercase a is 2, lowercase c is 1, lowercase c is 1, lowercase h is 1, lowercase h is 1, and you can see, you can compare, all the values will be correct. But the order is different here. Okay, because in a map, okay, the keys are stored in sorted order, sorted ascending order by default. Okay, that's why you get all the keys in sorted ascending order. Okay, sorted ascending order of characters will be the increasing order of their ASCII values. Okay, the ASCII values of a single space, this is a single space, is the smallest. Okay, if I add a few more spaces here, okay, you will see the frequency change. Okay, I added a few more spaces, it became 5. Okay, then you have uppercase letters in which s comes first alphabetically before t, and then we have all these lowercase letters in alphabetical order. Okay, so we have lowercase a with the smallest ASCII value in all the lowercase letters, followed by c, d, and so on. Okay, all right. So this is how you use an STL map to find the frequencies of characters in the string. Okay, and this is pretty fast because this is on. Okay, so this is the running the length of the string. So this is on, and find is o log n. Okay, where n is the number of entries in the map. Okay, so this for loop comes out to be n log n, which is pretty fast for this case. Okay, so I wanted to use the introduction of this map, okay, STL map, because STLs are an important part of C++ and they come very handy when you are going into competitive coding problem solving, and this is something you should know. Okay, they help making the task of problem solving much easier because of their inbuilt data structures. Okay, very powerful inbuilt data structures. Okay, now what if I want the output to be in the order of appearance of characters in the string? That is, right now the characters are output in sorted order. What if I want an output like this? Okay, because uppercase s comes first, I want as uppercase s, then lowercase a comes, so I want lowercase a, then lowercase c, and so on. So what if I want an optimized output with order of characters printed in order of their appearance in the string? Okay, so we could do something like this. Okay, we'll see how the runtime of this comes out to be. So I'll say string printed, okay, is equal to blank. Okay, also you can say printed so far, the way we took in the previous case. Okay, previous video. I'll say printed so far will store all the unique keys in the string. That is, whenever I find my character for the first time, I am going to append, okay, or I'll say push back to this string, which is ch. Okay, I'll add the character at the end of this string. Now push back will have the same functionality as this. Okay, you are appending a character to the end of the string, or this. Alright, but you cannot add one single character using ch. Okay, this is not allowed. You'll have to add more than one characters. To add one character at the end of the string, you use pushback, because strings are also STLs. Okay, it is a part of STL library, so you can use string pushback on a string. Okay, so basically adding all the unique characters in the string in this string printed so far. Okay, every time I find a new character, I add it to the end of the printed so far. So now my printed so far has all the unique characters from the string in the very order they appear in the string. So rather than printing the output in order of sorted keys will print output in order of keys appearing in printed so far. Okay, so we can copy this exact same thing. Okay, I'll comment this out. So rather than using an iterator here, okay, I say for int I equal to 0, I less than printed so far, okay, dot length I plus plus, get the character here as ch, printed so far of I, okay, and then print this character and its corresponding value, which is going to be frequencies of ch. Okay, all right, since we were using an iterator in this case to iterate to all the entries of the map, we were using first and last, okay, using this iterator pointer. Here in this case, we know the characters we are traversing. Okay, so we get the character from this printed so far, which is going to be unique character from the string, and then print the character with its frequency, which we can get from the map. Okay, so when I compile and run, I get this order of output in the original order of appearance in the string, the way it is here. Okay, and this has almost the same runtime in the as in the previous case. Okay, a little more extra time that we are consuming here is in adding this pushback. Okay, we are appending character to the end of the string. If you do this, okay, this is much more time taking than this. Okay, the runtime, amortized runtime for pushback comes out to be O, and if you check the documentation, right? So this is the best way you can add a character to the end of the string. All right, and the need for printed so far is so that we can have characters in their original order. Okay, we could also try an unordered map in this case, but the order of keys in an unordered map is not guaranteed. It could be in any order. Okay, and we want the original order of appearance of characters in the string. Okay, so this seems to be the best solution. If you people feel that there is a better solution than this, okay, to print the characters in the original order of appearance with O and log n time, okay, please let me know in the comments, right? I will be more than happy to discuss. Okay, the last thing I want to tell you is if you use unordered map, okay, and we use this, okay, this to print, okay, so we will have to change this to unordered map. I'll say unordered map, okay, unordered map, okay, all right. With this is not needed in for unordered map case, okay, this is also not needed. Okay, so for unordered map you will get the right output, but the order of characters is undefined, some order. This is not sorted order, this is not original order of appearance. Okay, right, some order. Okay, and there is no guarantee on this order. Okay, so if you just want the output and you don't care about the order of characters that are printed in the output, you could use unordered map as well. Okay, all right, so this was the code to find the frequency of characters in the string using STL maps and using an STL unordered map, and the idea was to make it as optimized as possible, okay, as the runtime as fast as possible. Okay, so I hope this was helpful and you like this video. So if there is any part in this video that you don't understand, or if there is anything that you have a clarification about, please let me know in the comments. I always try to answer all your comments, and you can always let me know in the comments if there is a question you want to solve or if there's a concept you want to discuss. So please let me know your thoughts about this video in the comments. Please like my video, subscribe to my channel, and thank you for watching.